All right, well, we're going to dig down a little bit deeper and talk about density testing with cold recycle mix, and we already talked about it quite a bit this morning, but hopefully we can clarify things a little bit. So I broke it down again into these 5 areas of content for my part of our 2-part presentation that I'm sharing with Brian. How to establish a laboratory reference value. My presentation is going to be sort of generic, and then that way whatever is the basis of the specifications is what the compaction method is what you would apply. Establishing a rolling pattern, finish rolling, mat density measurement, and then percentage of target density. So I showed y'all this graphic earlier when I spoke, and it shows how much moisture is changing throughout the process. And I hopefully got my point across that this is really important because when you make wet density measurements with a gauge, whether it's backscatter or direct transmission, the water that's in the mat factors into the wet density side of the gauge, and if the specifications require you to base everything on a dry density, then you have to pull a moisture sample and account for that number. And the way that works in the gauge is calibrated to measure the density in pounds per cubic foot, including the solid material and the liquid material in the test area underneath the gauge. That's the wet density side. The moisture side of the gauge is calibrated to measure the pounds of moisture per cubic foot. So you subtract the moisture per cubic foot from the total wet density per cubic foot, and it gives you dry density. So that's how the gauge works on the dry density side. So you can either control with a ratio of wet density or control with a ratio of dry density, but it's the same number because you're making a moisture correction to go either way. So on your rolling pattern, typically specifications are going to require you to have both a steel roller and a pneumatic roller. I mentioned in the last presentation I'm a big proponent of pneumatic rollers for hot mix asphalt because they can really help you to close the mat up when you're having a problem with dilation of the mix when you're trying to compact it. I have not had that same experience with cold recycle mix because it behaves so differently. I still would advocate having one on the job, not just because specification requires it, but because it could be that it could be an asset for you if you did happen to need it. I mentioned earlier to be careful with vibration and oscillation, because if you see and be observant, you need to have a technician that knows to be observant, because if you see the mix dilating, then if you see it scarring and expanding and opening up between the tires, if it's a rubber tire or at the edge of the roller, you might be doing more harm than good. But the idea with a pneumatic roller is it's supposed to knead the mix. Those tires are offset from each other. They're lined up to be offset with each other. And the idea with them is that when they make those tire tracks, they squeeze the mix together in between the tire tracks. And when you have a good stable mix, like a conventional hot mix that has all that new liquid in it, it really can do a good job of consolidating and kind of walking out of the mat, sort of like a sheep's foot roller if you're doing dirt work. But again, you got to be careful and make sure you're not dilating the mix excessively when the mix is not cooperating. But regardless, you need a good static steel wheel roll to finish, not just when you're done with compaction, but in order to get a good density test. And I can't really stress that enough. So you got to have the rollers set up so that the breakdown roller and the finish roller don't get so far apart that when you're out there with a nuclear gauge trying to monitor compaction, you need to have the finish roller on hand so you can get a good spot density test, good test spot. Trenton mentioned the compaction window is 30 to 60 minutes after placement, and you do need to have a control grip to establish your rolling pattern. And again, I advocate experiment with the mix before you ever start on the job, before you ever get into an official test strip. Make sure you understand the mix so that you have an idea of how it's going to behave when you start getting into specification compliance. So this is a shot when it's from the test track, and we were placing the Virginia mix on section S12, I think it was, and you can see we're right up behind the paver with our steel wheel roller, and this is a good shot because you can kind of see what hasn't been rolled up against that adjacent mat. Of course, the advantage that we had here was, you know, we milled a hole. We're placing this stuff inside a hole, so you got good confinement on the outside edges of it. In this mix, you get a lot of help when you're compacting it in a hole like that. So with finished rolling, it's really important for, you know, for work quality and also for testing because of the irregular surface that you get. You do get a reflection, the kind of the track pass, or you can get that with the rubber tire roller because this mix, tender really is a good word. It behaves in a little bit more of a tender way typically than some of the hot mix that you may have dealt with in the past. And I mentioned this earlier, any air underneath the gauge, underneath the nuclear gauge, is gonna throw your numbers down low. So when you have a high macro texture mat, like kind of an SMA, a rough textured surface, which some of these mixes have a little bit of a rough texture, that's gonna produce a little bit of error. But then when you have kind of the waviness of the rubber tire, that's gonna be big error. So, you know, you could put sand on it or mineral filler or whatever and level that out and account for that. But when you're setting, you know, when you're trying to monitor compaction, that's not really practical to do. That just might be something you could do for testing when you're done. So you always need that static steel wheel to get that smooth surface. And I'm a big advocate of do a lot of tests with a nuclear gauge. It costs you nothing. You know, you got a technician already on the job, you got the gauge already on the job. So do more testing than you could ever possibly need, because that way you have a better understanding of the mat. You know right where you are in the kind of the buildup of the density in that mat. Don't focus so much on final density numbers. Just make sure you know when's it increasing and when's it starting to fall off. This is a really good shot, and this is from 280. And this kind of is like the picture that Mike showed. You can see the kind of damage, really, and it is, I'd call that kind of damage, just disruption in the surface of the mat that you get from the rubber tire roller. And you set a gauge, you can imagine you set a gauge down on that, what are you going to get? It's not really going to give you anything useful because the texture's rough and it's really grooved out badly. So with mat density measurement by specification, stay at least, and this Trenton I think mentioned this when he was discussing the specifications, stay at least 1.5 feet from the edge of a cold recycle mat. And I'm a big advocate of, yeah, you know, make sure that the whole mat is in good shape, but I tend to focus a lot of effort on the wheel pass. You know, you need to make sure that you're good on density with non-destructive testing out close to the edge of the mat, but it's the wheel pass is really where the product is going to see the most stress. It's going to see the most action, see the most shear. So we focus most of our testing in the wheel path and just make sure that we're okay out to the edge of the mat. These specifications require direct transmission. Again, keep in mind, as like I said earlier, the gauge is really only going to go 2 to 3 inches. You know, and the majority of the measurement in the gauge in backscatter mode is going to be the top 2 inches. So you know, people will tell you 2 to 3, but you're getting very little influence from that 2 to 3 inch distance from the surface of the mat. So if you're putting this in at 5 inches like we did on the track, or at 4 inches like we did on US 280, it like we said, it tells you nothing about what's happening at the bottom of that mat. So to do direct transmission, we did try to do drill pins in the FDR Foundation that we did for y'all back in 2012, and it wasn't possible. I mean, you can't do it. I mean, it's just too robust a surface. You know, you can't drive a pin into it. But with the hammer drill, how many of y'all have used a hammer drill on asphalt before? Works beautifully. You know, a good like a Hilti drill, a sure enough heavy duty hammer drill. It's like going into butter. I mean, it's not hard to do at all. It just runs right down in. Of course, you got to have a generator or a battery inverter on site to run that, but it's a 110 powered tool, so it's really easy to use. And we actually use a hammer drill in this dry augering. There's no water. It's not like doing cutting cores. We use a hammer drill to do base and subgrade moisture content measurements. You can actually take the trimmings off of the auger stem and put them in small sealed sample containers if you're concerned about moisture, if you're doing research on moisture, whatever you're trying to understand what you're building on. And you can cook that out in the lab, and those numbers will correlate extremely well with actual undisturbed moisture content. So I'm big on the hammer drills. And that's just because even, thin lift gauges are even worse, because they have conventional nuclear gauges will have one tube in the back or a pair of tubes in the back. The thin lift gauges have an array of tubes that are arranged kind of in a pattern inside the case of the device, and they even go shallower than the conventional gauges do. So that's not going to really tell you what you need. Again, as I mentioned earlier today, you just need to make sure that whatever you're measuring in the field, you're comparing it to the right number in the laboratory. So we either compare dry density in the field to dry density in the lab, or wet density in the field to wet density in the lab. It's a specification decision for the department to make, but in the future I'd recommend you take a really good look at wet densities, just because it's easier for y'all to police and enforce, and I think it's a more practical value for contractors to know where you stand in compliance with the specifications. Regardless of what you do, because you can do it either way, it's really critical to make sure that everybody's communicating the same values. You can imagine how messed up it would be if you've got, field talking about wet values and lab talking about dry values. You think you have a certain level of compaction, and then you find out that you're not anywhere close to where you thought you were. So, and it's important not just for compliance with specifications, but make sure everybody is on the same page. And again, for density, you're not worried about over-compacting this material. Over-compaction is never going to be any kind of a problem. So, with hot mix asphalt, some state specifications, you get penalized if you go too high, and you get penalized if you go too low, and this doesn't work that way. So your technician should just be focused on obtaining the maximum value behind the paver. So don't be concerned at all about over-compaction. For that reason, you can completely run the job, establish a rolling pattern, and do all of your QC testing just with uncorrected values. Don't even worry about what's happening in the lab. And if you have good due diligence on the job, the right equipment on the job, and you're doing everything right in your testing program, you're going to be okay. And we came out, I think, 103% when we did y'all's test sections on the track back in 2012, and it turned out great. So this is a picture from 280 in the summer of 2015 when Vertgen was on site to help us with this. And I got this in here because the contractor has moved off. They're on down the road. My personnel now, they're out with my gauge. So we'll have two completely separate gauges, and the contractor, I'll tell them, look, you're responsible for getting density on this in order, to get numbers that meet our specification. They'll police the job with their device, which they've calibrated. They got a zero correction factor in it. And then when when they get their equipment off and they're satisfied that they've got all they're going to get, then my guy goes out with our gauge and we do our density measurements. But what you have to keep in mind is that if you're comparing, and we were talking about this earlier, it might have been on a break, but if you're comparing wet density in the field to wet density in the lab, then the incentive for the contractor is to get finished with compaction as quickly as possible and get the final gauge measurements, because the longer it sits, the more water is going to come out of it. Your wet density number is going to go down, so your ratio compared to lab wet density numbers is going to go down. So the density level that you look like you have, it's going to look worse if you wait longer to get the final numbers out in the field. So it's in everybody's best interest to finish as quickly as you can, so So we got out on this just as soon as we could to get our gauge measurements, and we were still a little bit on the low side when we went back and cut cores, and we compared dry density to dry density and wet density to wet density, and that's what you would expect. And again, I've got this on here just to stress the fact that moisture is constantly changing, and that's why you really want to get this done just as quickly as possible. Making sure that you're in a similar moisture state is the key, and depending on how how the state is going to apply specifications and how you're going to police yourself on the job, you can come up with a correction factor. You know, if you're not comfortable just kind of going with a relative density and looking for peak values, you can look at the mix design and cure specimens out. You know, put your lab compacted samples together, just your mix design samples, maybe during a trial run, if you do sort of a couple of loads as a test run before you start up on a real job, and you can measure moisture loss throughout the process, just like I did on this curve before you ever start on the job, and you can come up with your own correction factor. The math to correct the densities as you go is not complicated. It's not real hard. You just have to look at the percent moisture and sort of imagine this, you know, this imaginary cubic foot of mix that the gauge is measuring. You put the moisture back, you know, you increase the moisture level or decrease the moisture level in that theoretical cube and recalculate the density number. So it's not real advanced math. So you know, I would encourage you, again, do your homework on the front end, do the test runs, make your own mass loss measurements, cure the samples out, you know, leave mix in an oven for a couple of days and leave samples sitting out for a week and let them dry out good, and bulk them, measure your densities to get a good handle on how things are changing in the lab over time. And I would encourage the agency to look at wet densities in the core lock device with the bag, you know, kind of towel things off when you get them out of gyratory compactors and bulk them there, and then use that to police the job.
So in this part, I'm going to walk through a little bit about walk through the specifications on the density side. And I stuck in a quote here from an article I found. I think some folks out there know Jim Schrockman pretty well. This is a quote about hot mix asphalt. I think it's somewhat applicable to the cold recycling work that we're talking about. But for hot mix, Jim said in this article, a single most important factor that affects long-term performance is the density of the mix. And I think there's some truth in that for the cold recycling. Maybe we don't know exactly what that percentage is. Maybe it's not the most important, but it is an important feature. So this is not new news, I think, to any of us, especially that are familiar on the hot mix asphalt side, but it's something to pay attention to, especially in the recycling world. So as I walk through, I'm going to talk about the specs. I'm going to kind of cover CIR and CCPR put together the density components, because they basically are the same for each piece. So some of the tools that we have, the two main tools, the way I see it for doing the inspection work, one is the inspector and the second is the nuclear density gauge. The inspector can tell a lot what's going on, especially if they're an experienced inspector and have seen this material before. They can tell a lot what's going on just by looking at what's coming off the back end of the machine or coming out the back end of the paver. You can visually identify changes in the mixture properties by really looking at the color, the particle distribution, recycling agent dispersion, all those kinds of things. You can tell a lot about the quality of the mixture. There's no way really to quantify it, but you can tell a lot by just visual inspection of what's happening. Especially changes. You may not be able to quantify it, but you can at least qualify it. Nuclear density gauge, here we're going to quantify the measurements. We're measuring density, but again, the density value that's returned by that's also influenced by the binder content and influenced by the moisture content. So echoing what Buzz has said, those are important factors to keep in mind. The nuclear density gauge, the spec calls for it to be operated in direct transmission and calibrated within the previous 12 months. Again, we've talked about it before, but why direct transmission? Because we're interested in knowing the density at the bottom of the mat. It's really the main concern. If we're talking about a thinner mat, I guess some states, if they have a limit to the thickness that they can place, their specifications may allow a thin lift gauge to be used. But we require direct transmission. And again, are there exceptions? Probably. In terms of the acceptance steps for density, we're starting off everything with the job mix formula, as I mentioned yesterday. The job mix formula gives us our target density, the value we're trying to shoot for in the field. And so that's the first important step. There's a roller pattern, a control strip involved, and the control strip following VTM10, and then the lots and sublots, and these are how we're going to assess our density. So for the job mix formula, again, the JMF is the mix design, and the biggest say on here, again, the density target. What's the target density we're trying to reach in the field? Usually it's going to be the maximum density we obtain in the lab. There may be some reason why it may not be the maximum, depending on the other properties we see during mix design, but it probably is. So again, that's the value to which the field density is compared. A project may have multiple mix designs, and in fact, I think that makes sense to have multiple mix designs, unless you're in the case where you've got a large enough project and you've got, let's say, a dedicated wrap stockpile doing a CCPR operation. Maybe your stockpile is consistent enough that one gradation and one job mix formula is good enough, but I think for a CIR project or for a CCPR project where the wrap is coming directly from a milling operation in the field, I think it makes sense to have multiple mix designs to be able to bound that gradation and know if there are any changes on your job mix formula that you've got that accounted for ahead of time rather than discussing it with the agency in the middle of construction. So JMF may need to be modified during construction. I think Mike and I talked about that a little bit yesterday. He said there are likely to be changes in the water content during production based on the moisture coming off the wrap stockpile. There may be some other changes that are needed. So I think when we do our just-in-time training for the agency, I try to make sure that caveat is in there. I said, you know, the JMF is not absolute. There may be some changes needed to it as we go down the road. But it's up to the department and the contractor to work out how significant a change is okay, just, yeah, let's go, or we have to revisit and make a new job mix formula. So the roller pattern control strip, according to VTM10, density test locations are marked, and it's acceptable. The field proctor is at least 98%. This is some language we need to work on in the spec. The spec states maximum theoretical density, but we don't actually measure maximum theoretical density in the job mix formula process. So really, the spec ought to read target density, and that's one thing I'm trying to make sure we have our language consistent. Everything needs to be target density rather than maximum density or maximum theoretical, all that stuff. That way we're using the same language in the job mix formula and in the field of target density. So again, as we develop these roller patterns or control strips, one thing I wanted to add in here is that additional control strips may be needed. If there's a change in equipment, if there's, let's say, an equipment breakdown, new piece of equipment comes in, composition of the material. Again, some of the photographs we've seen are all nice and consistent, and everything looks very uniform, but you could end up with the case, again, as we're talking about whatever, essentially the material that's there, especially if you're talking about, you know, field-obtained wrap rather than stockpiled wrap. Field-obtained wrap, that could be variable. It depends on whatever maintenance procedures were done. And so if the composition of that material changes over a long enough distance, there may need to be a new procedure set up. So lots and sublots. The standard lot is 5,000 linear feet with 1,000-foot sublots. There are lots of exceptions. All that's detailed out in the spec. And there's also wording in there dealing with partial lots. I didn't write all that up here, but it's in the specification. With approval, lots can be increased to 7,500 linear feet if the daily production exceeds 7,500 linear feet. So the contractor shall test each lot for the density acceptance based on readings from 2 random sites, now within 18 inches or 1.5 feet from the edge. And the sublot average is compared to the target density, or the density target, to determine acceptance. So again, the sublot average. Required density is a minimum of 98%. Again, spec says maximum theoretical, but again, the wording should be target. Each lot should be tested for density at 2 random sites per sublot. Average should be compared to the target. Oops. So each lot includes 10 measurements for the lot from the 5 sublots. If 2 consecutive sublots are less than 98% of the target, notify the project manager, take corrective action, and verify with field proctors. Stuff to watch. A really technical description. But again, this is kind of the qualitative things that an inspector can really pick up on that I think can help ensure there's a quality product. Color is a big thing. May indicate a change in the moisture content or recycling agent content or a lack of active filler if the filler somehow didn't get added in there. Color can tell you a lot. On the foam side, stringers are a thing to look for if you've got material that's being processed and you're down towards the temperature minimums. And stringers are just like what it sounds like. It's globs of foam kind of strung out together rather than individual spot welds that we've seen in some of the example photographs. So the stringers will be kind of like a glob of the foam in there rather than being nicely dispersed. If that happens, the temperature is too low, or there are other issues in the foaming process if you don't see those spots. Again, the specifications talk about 50% material temperature, so temperature of your wrap. Significant changes in the density may indicate changes in all the above or material composition. It's kind of hard to just look at the density value to see exactly what's going on, but we'll have to, it's at least an indicator to say, hey, there's some change in the process. You need to dig further into it. The roller operation, I know it's fun to count number of roller passes, but again, it's a key component to make sure that we're achieving the desired density of the material. So counting and verifying the number of passes, the speed, and the number of passes in the vibratory versus static are all important things to consider. And again, those are easy steps that the inspector can do. The temperature in itself is not so critical as long as the material is greater than 50 degrees F. You know, if we're 75 or 80 or 100 degrees, it's probably not so big a deal. As long as we're wary of what happens to the moisture content at that point, the hotter we get, the faster the moisture content is going to drop. And the compaction needs to be completed before the moisture reduces. And the way I look at it too is that the cement that's being used as an active filler is forming bonds as soon as that material has water on it. And so I think it's important to make sure that compaction process happens before those cement bonds are fully formed, because otherwise you're breaking the bonds. And so you're losing a lot of the benefits that you saw in the mix design. Again, using these active fillers or chemical additives, the reason we're putting it in there is to improve the moisture resistance. So the rollers, why do we need such heavy rollers for this stuff? We need such heavy rollers because we need higher compaction energy. Unlike a hot mix where you use high temperature to reduce the viscosity of the binder, to reduce the viscosity of the mixture, here we've got high internal friction because of the low temperatures, so we need heavier rollers to be able to compact the material. The specification says 20 to 25 ton pneumatic and 10 to 12 ton double drum vibratory. In terms of the timing, Mike showed a couple of great slides of this, of showing the rollers right up behind the paver on the foamed asphalt. That's really an important step. Make sure to compact those immediately as it's being paved. But for the emulsified asphalt, as a recycling agent, as the emulsion breaks, and look for that color change going from brown to black, and that's when the rolling process needs to happen.